Hi, my name's Thomas Hancock, and today I'm going to tell you about my new decision field theory model for capturing the impact of experiences in preferential change. This is work that I've done together with my colleagues at the University of Leeds. We are part of the Institute for Transport Studies, and I'm explain shortly how we've landed at the Mathematical Psychology Conference. So, an outline of my presentation, I'm going to talk about the motivation for this work, talk about the data we've used, our modeling framework, some results, and discussion of next steps. So, motivation of the study. So, we are also part of the Choice Modeling Centre at the University of Leeds, and choice modelers tend to focus on models that have more sort of econometric base rather than a sort of psychological base. And that means we try to do slightly different things than mathematical psychologists. So really, it's almost a case of we just want to understand the outputs of decision-making process. Can we explain the output as a function of the inputs? Whereas I say mathematical psychologists are much more interested in the process. How do you get from the input to the output? How does the brain work? How does it make the choices that we make? And this makes a lot of differences in terms of what the models mathematically look like, their mathematical structure. But increasingly within econometric choice modeling and transportation research in particular, we're finding that econometric choice models aren't quite sufficient for what we're really trying to do, and this is leading us to move towards the models that you guys have developed within mathematical psychology. So the motivation for this work is really we're looking at repeated decisions in travel behavior. So there's substantial amounts of repetition when in travel behavior data. For example, travel modes when you commute to work, how much distance you might travel each day, travel route choice when driving. You're probably going to go the same route to your kid's school each day, for example. These sort of decisions have really significant implications for city planning and development of infrastructure. And this is where sort of transport econometrics comes in. We're kind of interested in trying to inform policy and, should we build this new road or not? And to make good decisions on that sort of context, we need to really understand what will lead to preferential change. So, for example, how can we nudge people towards greener travel modes, or when is inertia really critical? So it is going to be critical in forecasting future travel behavior. So standard transport econometric modeling approaches, really we use random utility maximization, and this has dominated for decades. And this is based on this sort of concept that there's this utility, this sort of quality of each of our possible alternatives in a given choice scenario. And this will depend on the characteristics of the decision maker and the characteristics of the different alternatives. So what this means is that when we try and capture inertia, typically what we have is a case where the utility of an alternative in the second scenario will depend slightly on the utility in the previous step. So, for example, one way of doing this would be that if you've chosen an alternative in the first round, then that will influence the utility of that alternative in the second round. So that's basically the utility of the alternative is going to gradually increase if you keep choosing it. Also, you could just look at utility differences from previous scenarios, so that can be factored in as well. However, in mathematical psychology, there's a lot more options here because obviously the models try and capture the decision-making process. So maybe we can look at that decision-making process itself in terms of trying to explain inertia, trying to explain preference reversals. So, for example, we've got an accumulator model here, and imagine that you're making a choice twice. So your first process, you're considering 3 different options, and you might end up choosing this green option here at the end. You then actually experience this. You've chosen an alternative. Maybe, this is mode choice again, travel mode choice. You've landed on choosing car. You actually experience car at that trip. And then you're making the choice again sometime later. And maybe your initial preferences here are the same the next time. Or maybe not. So maybe something that happens here is going to reflect on our process here. So maybe something happens here. So basically, what happens here? This is kind of what we're interested in. How can we fill in this gap? What happens as a result of the experience? What happens as a result of the fact that we're making a repeated choice at a different time? So there could be just no change in preference. So you sort of conclude the decision-making process and you sort of just land there and then you just stay there. But that means that your initial preferences might change at the start of each decision-making process. So potentially, you're going to change your alternative. You're sort of building on what you've already been considering. And this is maybe more likely in a case where you don't actually conclude your decision and you sort of keep thinking about it later. So maybe for a longer term choice, for example, choosing which university you're going to study at, maybe consider that over a long periods of time, and you didn't just start afresh every time you started thinking about it, but you built up preference over time. You maybe visited different universities, and then something happens at each stage. It might be that there's some sort of depreciation over time. So maybe you sort of forget some information and you're sort of almost starting fresh, but not quite. You've built up something from your previous consideration of different alternatives. Or maybe only the preference for the experienced alternative changes. So, I choose something here and I actually experience something. So, if it's a good or bad experience, that might affect my preference moving forwards. So maybe, in this case, it's not changed much. But another case, I might choose to travel to work by train. The train's delayed. I get held up. I miss an important meeting at work. And, next time I'm not going to choose train. So our key research questions here, how can we best model the change in preference as a result of experiencing a choice? How can we best capture preference reversals? Also, can we actually try and better understand the decision-making process here? So in the data set we're looking at, we've got eye tracking data, EEG data, stress measurement data. Can we include those to better understand unobserved process here, this thing here? What is happening in this stage here? Can we understand that a bit better using proxies for the decision-making process? So I'm going to talk about our research project Nexus, and the data set that we have is quite comprehensive. It was designed for something entirely different, really, originally, but we've managed to look at this in many different ways. So one of the main aims of this project is to understand future mobility and understand the sort of preferences towards new travel modes that are maybe upcoming or going to appear in the future. So the first choice setting that we have is between current modes. So this is just fairly standard stated preference, multi-attribute, multi-alternative choice. And people see these sort of choice cards that look like this, and they have the different options: private car, ride-hail, bus. And these are described by various very standard travel modes type attributes: cost, time, number of passengers, carbon footprint, how comfortable it is. And people make these choices, and they face 4 choice tasks like this. We don't give to people too many; it's quite complex, so we don't want to overburden people here, overburden our respondents. The second choice task type, tasks 5 to 8, are based on upcoming modes. So private car compared to a self-driving car that is shared, and a self-driving car that only you are in. So this is kind of like a taxi, and this is kind of more like a shared Uber, for example. And we again ask people what their preferences are, and these attribute values change between the different scenarios. I should have mentioned that before. So yeah, we have different attribute values, and you see how that changes people's preferences towards the different modes. The third type includes the two new futuristic modes. We call them air taxi and hyperloop. So these are modes people just simply haven't traveled by before. So an important part of our research is understanding preferences towards new things before they appear in the market, and therefore you can start making some forecasts as to how much will someone actually choose this if we put it in the market. We got people to do this in virtual reality. So what this looked like is we actually made people make each of these 12 choice tasks that they faced. They faced them each twice. So they faced, for example, they looked at this choice scenario cards here. They chose one of the alternatives. Say they chose air taxi. They then experienced a simulation of that air taxi trip in virtual reality. And then they would face this choice task again. So, it was a case of, how did that experience impact their preferences? Would they still choose air taxi? So here you can see myself testing out the driving modes. And I should mention that if you choose private car, you actually have to drive in virtual reality here. So, I'm actually steering, got pedals down here as well. So yeah, I'm actually driving here. in the virtual reality session. So because it's virtual reality data, it's quite a complicated data collection process. We connect people to VR. I'm not wearing the EEG headset at this point, but we did have that. We did have stress measurement devices on the fingers of the participants as well. And we had 70 participants making these choices in virtual reality. We had the three different types as three different sessions because it sort of took about an hour for each of those three sessions, because we wanted people to experience sort of 10-15 minutes of each of these trips each time we chose them. So we had people back 3 times. Not everyone came back all 3 times, but we got 45 people who completed all 3 rounds. So quite a significant amount of preference reversal. 22% in the first case, 23% in the second, and a bit less in the final scenario. I'm going to use decision field theory here. I've not got much time, so I'm going to just skip over that, assuming that you know something about decision field theory. We use a sort of version developed by us in a previous paper, and that's on transportation research part B. Go and have a look if you're interested. And now how we're going to capture this sort of preferential changes, we're going to look at changes in the initial preference matrix. So depending on your experience, this might change. So for example, a person might choose the third alternative, and then in the start of the sort of choosing their preferences, the second time the third alternative has a shift away from 0. And we're also going to include stress measurement data. So the idea being that we can try and link the unobserved process here with something in the decision field theory model. And so incorporating stress measurement data, maybe preference reversals happen more if someone's had a particular driving experience, for example. So firstly, our base choice model completely overpredicts the number of preference reversals because at the moment we've got this set up such that there's no differences between the choice settings, whether it's an online version before the experience or after the experience. And the estimates of the different attributes look about kind of what we're promising. Differences in settings make a difference. So for example, we see that people are more likely to choose bus and train if they're doing this survey online. They do it in virtual reality settings, then they're less likely to choose them. So maybe reflecting the fact that if they actually have to experience these sort of more uncomfortable travel modes, they're not actually going to choose them. One additional parameter for capturing the fact that they might choose the same before and after makes a huge difference in this model fit of the after experience. So really big reduction, a big improvement in the log likelihoods. And very significant parameter estimates. So this is basically saying a preference value of 32 at the start for the chosen alternative, and the one they've just experienced. So a real sign of inertia here. People are kind of tending to stick with the alternative they've just chosen before and then choosing it after. There is some memory effect between choice tasks. So this is going from choice 1, 2, 3, 4, for example. But differences between online and virtual reality. So people online tend to choose the same alternative. People in virtual reality settings tend to choose different alternatives. So a negative weight for the alternative they've just chosen before. And finally, the impact of stress. How does this actually, what actually happens here? So basically what we've done here is we've correlated the stress measurement data with the likelihood of choosing the same alternative again. A couple of alternatives does appear to be that people do change as a result of a stressful experience. So what we see is for when people choose the bus, if they found that stressful, then they're less likely to choose it again. Maybe it felt quite crowded in virtual reality settings. So, you know, if you're making that choice initially when you don't sort of see the crowdedness, you might misestimate how unpleasant that will be. And similarly, when people were driving in the second scenario, they became less likely to choose it if it was stressful. Swapping to just being a car passenger in autonomous vehicles is I suppose, a fairly easy decision, so people did that. Finally, conclusions and next steps. Choices are inextricably linked, but the use of virtual reality data, we think, helps disentangle the effect of experience and preferences. Stressful travel trips can result in participants changing travel modes. That's very clear from our data. and unsurprising from real life experiences. There's some degree of inertia even in online settings. Decision field theory allows for many possibilities for how to capture experience. Next steps, there are many different ways we can still model this. I've not even started modeling some of the different possibilities. And there's also many more types of data here to explore. I've not even looked at the EEG or eye tracking data yet. So we've only just finished this data collection process. So, a lot more can still do here. And different model frameworks possible here as well. I'll be very interested to hear your thoughts, particularly on, what should I really be focusing on here to try and improve the models and improve the performance. So thank you for listening. Any emails, please do email me here if you want to follow up this. Thank you very much.